Hi, this is Monica and Geoffroy again, and this time we're going to present homework 0, part 2. And we did the code yesterday, but we had some issues with machine and Google Hangouts, so we decided to do a code review. We're going to look at each of the 3 methods of part 2, and we'll explain what we did, why we did it. We'll look at the tests that we run, and we'll basically go through the work we did. So let's get started with the first method, which is the hello.
Yes.
And that was a pretty simple one.
Very simple, yes.
So I'm not sure what to say.
The typically example of any language, programming language.
Yes,
Yeah?
that's right.
Yeah.
Exactly. I guess we chose Bob instead of world, but we could have done hello world as well.
Yeah. Well, that too.
So yeah, I think there's really not much to add. This is very straightforward. Let's take a look at the next one. It starts with consonant.
Yeah.
So here we have a method that's going to return true or false, and actually checking to see if the first letter of a string is a consonant. So I guess the idea was to check if that first letter is not a vowel. Since that's a smaller set of characters, it's less typing. So it makes it easier.
You know what, Jeffa? I didn't realize yesterday, and the grader from EDX take this as correct, but we didn't.
I'm sorry.
We didn't take care of this instruction.
Ooh, hold on.
Be sure it works for both upper and lower case and for non-letters.
Well, it does work for.
It does work, but I think.
Well. Yeah. No, I think the way you did it.
But for example, if we put a test here and we put a non-letter like that, what do you think it will be?
It's going to return false. And which is
true.
Oh. How come?
It should return false. So I think we have to change. It's just a fact. I just read it. Just a fact.
Oh, that's great.
Yeah, it's the same. It's exactly the same way, but in the opposite direction. Like here it is not there. And let's see it like that. It should work too, right? I think.
Um,
No.
hold on,
Why
hold on,
not?
hold on, hold on, hold on. You
Ah,
need
yeah,
this,
yeah. Sorry, sorry.
and you're gonna have to remove what they consider.
Oh, yeah, right. Sorry.
No, 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 no. You're good. I think it was a very smart way to do it, but yeah, you have to go through your string and make sure you get rid of those. Right.
If
So
what
that should do it. But okay, go ahead, run it.
save and run. That is false, as we expected. Okay, that works fine. Works better.
Yeah, no, and yeah, exactly. Because of the requirements, you have to take care of non-letters. So that's where, yeah. And you know, I think you remember how in the instructions they said that you might want to look at regular expressions,
What?
and, and I think there's probably with the regular expression, there's probably a way you can say you want just this in a much more compact way than actually typing all the consonants in uppercase and lowercase. Actually, you know what? If I may suggest something, um, um, so you could probably cut that in half. Not that it's very important, but you could do S to uppercase, and then you don't have to worry about half of that,
Yeah, I know. I think yes.
right? And you just say, um, actually, you can probably say it here.
I think yes.
I'm not sure if you can do it on a character or if it has to be on the string. But anyway, maybe we shouldn't care too much. Um, it,
I think it's dash upper, or
that's probably it's it's not the most concise way. I'm sure that with the regular expression
yeah,
it,
sure,
it,
yeah,
it
sure.
it'll be shorter. But I'm not a regular expression expert, so I would have to look it up to see how you can say, okay, I just want the consonants and uppercase or lowercase, and at least this is a lot more. I mean, it's easier to understand when you think about it,
Yes.
because a regular expression, I don't know about you, but they're not easy to understand when you look at them.
Yeah.
It requires experience to be able to read them.
Yeah, to read every word, every letter in the instruction.
Hmm. Mm.
Yeah. So that is
Okay.
this explanation, no? We
Yes.
didn't explain, or we explained the code before I start talking about this. Uh, I don't remember.
Yeah, I think that's good. And it shows very well. You have all the consonants, and you look at each. Well, actually, with includes, you just say, hey, does it include? Well,
Well, the last one.
hold on. Oh yes, the first one. So we're only checking on the first one. Yeah. So that's yeah. So that's it. Yeah. And the third one was binary multiple of 4. Yeah, that's a little weird.
That was very fun.
So here we have a method with one argument, and it's a string that represents a binary number. So we have examples down here of such strings, and we have to make sure that the string is a valid binary number. So they're asking us to have a test to double check on that first. And once we know it's a valid binary number, then we have to figure out whether or not that binary number is a multiple of 4. And yeah, let me look at what we have here. Ah, yes, yes. Okay, so now I remember.
Yeah, after we try to do with another method, we have to use a for loop.
Yes, yes. Just a regular for loop.
Yeah, we had troubles with other way what we was trying yesterday.
Yeah, trying to make it more compact using some kind of each or collect or whatnot. But so here we're looking at each character in the string. So that's what the loop is going to do. And so that's binary number at a given index. And we're going to check to make sure, that's the include, that it's inside that little set of 2 characters, 0 or 1. And if it is, then we keep chugging along, looking at each character. And if it's not, then obviously we have something that is not good, so we just return false. And that ends the method, and we've returned false because we didn't have a valid binary number. Does that sound good enough to you?
But
Monica?
here no doesn't end the method. Here ends the part when we check if it's a binary number. When we check that it's a binary number, then we check if it's multiple of 4 in this line, right?
Okay,
Did you
so
explain that? Because I didn't realize.
no. Say that again. I'm not sure. I'm following what you're saying. The return false here.
Yeah, return false here because in case of this if statement result true, then because the number of the input that we put here is not a binary number. In this loop, in this for loop, we only check if that is a binary number.
Okay.
Yeah. Then when if that is not a binary number, if we have another number different to 1 or 2 or a letter or whatever, then return false and end the method, end the loop. But then if the statement the for loop results true, then return the result of this Boolean
Mm-hmm.
statement, that is that both cases result, the both last digits of the
Mm-hmm.
input are zeros because there is a multiple of 4.
Right. Right. Exactly. Yes. Yeah. And you know, I think that that pretty much does it. So um, you know, maybe we can add that. Um, you know, another approach we looked at was to convert it to uh, decimal, and then you know do division by 4 and look at the remainder. But because in this case, um, the condition we're given is to validate that that binary number is a multiple of 4. We can leverage the fact that in binary 4 is 1, 0, 0, and we can apply some binary math uh, to our problem, which allows us to write the condition, you know, this way. Now, obviously, we don't have a very generic method, so if they come back and say, hey, you know, now we need to make sure that that binary number is a multiple of 6, you know, that might not work quite as well.
No, we have, in this case, we have to convert to decimal and then check.
Yes,
Yeah.
yes, yeah. So, anyway, that was you know, our answer to the requirements. So I guess that's enough for this for this specific requirements.
Yeah.
And that's it. I think we can run it. No, we did, or did we?
No, we didn't.
We didn't. Okay.
No, we didn't.
So we can run it and see that, you know, the first one is true. Second is false. It has, you know, an A in it. Next one is false because it doesn't end in 0, 0, so it's not can't be divided by 4. Um, and then the next one ends by 0, 0, so it's true. And the next one ends in 0, 0, but it